YouTube channel. We educate and we learn. Today, I would like to share some basics ideas of the physical space, phase space, and configuration space. Let's get started. Okay, so here is what I have is physical space. That is two-dimensional space, which is a real, real Cartesian plane. So it is the Cartesian coordinates. Here is a x-axis and here is a y-axis. So there is three rigid body, which is three rigid objects, which is are not moving. So this I name these three objects A, B, C. So how I'm defining these objects by I'm defining these objects through the vector. It's easy to make sense the vector in physics. So that's why I'm defining these three rigid bodies through the vector. So how the easiest way to define these three objects is by the vector, which is a function of one variable. Here is an input x, and you get an output y. So that's how you define these all three objects. Okay, so let's move on to the third picture I have in the screen. So there you what you are saying is you are now you are saying a cluster of objects instead of a single rigid body A. Here is instead of a rigid body B, here is another cluster, and here is a instead of having C, I have a another cluster here. So there's three cluster. uh, so in this three cluster, we can think about them as some sort of molecules or atoms, whatever you want to think about it. So it's again a Cartesian plane. So here is a y-axis and here is a y-axis. Okay, so how you gonna define all these three all these all these types of molecules, all the clusters of molecules? How you gonna define it? Again, you need to use the vector. That's how you define all these objects where is in the two-dimensional plane. So it's a bit harder to keep track of all these objects in two dimensions with using the vectors, or when you have a bunch of molecules or a cluster of something. So that is where configuration space come into play. So here is again I have a plane, but it is a higher dimension. Then I have the Cartesian one, which is two dimensions. So this is higher than that. um, so here how I'm gonna define this three cluster by just a single body. Okay, so here is one, here is one. Okay, one, two, three. It is an A, it is B, okay, it's C. So in this case, what I have is that three single objects, which is the which is composed of all this cluster of objects. So here what I'm doing, to have a mathematical advantage, I'm taking all these clusters into a higher dimensional place, and I'm thinking about the cluster as a whole, not all these single objects. So so that mathematics comes easier. We can keep track of all these three objects, but in a higher dimensional plane. So it's a higher dimensional space. So instead of thinking about a cluster, we are thinking about a single objects, which is equivalent to a cluster in lower dimensional plane. Okay, so here let's have a look at my second graph. Here what I have in the slide. So in this graph, you can see there is three vectors, three objects first, or A, B, C, which is heading toward three different directions. So A is heading toward heading upward, B is heading kind of middle between A and C, C is heading downward. So what I have here is a two-dimensional real Cartesian plane. So here is the x-axis and here is y-axis. Okay, so in this case we have the momentum. So here these three objects is not rigid anymore. They have the velocity and they are heading towards some direction. So we have to account its velocity and mass. So we have the momentum. So momentum and the position, these two things are needed to define an object, because um, no objects stand still, so they constantly moving, like our earth and our galaxy is constantly rotating, so everything we have to account so to get as correct as possible mathematical ideas, so we need to account, we need to take it into take the momentum into account. Okay, so now let's have a look at the our fourth picture, what I have in slide. Okay, so in this case, it is same as the two-dimensional Cartesian plane. Is here is the x-axis, here is the y-axis. So what I have is a cluster of objects. Okay, you might think about this as a galaxy. It's a elliptical galaxy, like elliptical galaxy, like this. All right, so it's an elliptical galaxy. So here are all the other planets, stars, heading randomly. So and there is another elliptical galaxy, and here is another one. Okay, so three elliptical galaxies. So these objects in inside these galaxies are stars, for example, and they are heading in different directions. So they have the momentum. They are rotating. They have the so we have to take into account the momentum. So here I'm defining the moment and the direction of the velocity through all these vectors. These are all vectors. You see that the linear these lines over here. So these are all vectors. They are indicating their respective directions. So it might be heading. This might be heading downward. This might be heading upward. This might be heading somewhere upward. Okay. So what we have to we want to think about is that again we would like to compact these ideas into a simple idea but in higher dimensional space. Okay, so we would name this space phase space. Okay, it's a phase space. In phase space, we both take into account the positions and their momentum. So here all I have is a bunch of objects. Let's call a elliptical galaxy. Let's name it A. So I'm going to think about it as a point, a single point. This galaxies, when I'm not sure you are whether or not you are familiar with the cosmic waves. When we look at the cosmic waves, every galaxies, whether it's a elliptical or another types of galaxies, it may look like a single dot, a single points. If you look at the cosmic waves, so here I'm going to think about the a single dot instead of a whole bunch of random things. So, okay, so here is the here is A, here is again B, here is C. So this cluster, for example, it's an elliptical galaxy, so I'm going to consider this cluster a point in the phase space, which is a higher dimensional plane than this plane, the real coordinate, real Cartesian plane. So here I'm taking the whole cluster as a point in a higher dimensional space, and I'm also going to represent this all these vectors, all these mass in these elliptical galaxies, all the vectors of their stars, and for example stars and planets. So all their vectors I'm going to take into account a whole just one higher dimensional vector. Okay, so I'm going to um, define all these I'm sorry, so it's going to be upward because the direction was in upward. So okay, let me remove this. Okay, so the direction is going to upward, so just one higher dimensional vector is in one higher dimensional vector. Okay, is a higher dimensional vector. So it is what it is doing is it's representing all these stars, all just a whole cluster in a higher dimensional plane. The plane is phase space, the same as with this. Okay, the B. So the direction is going to be a little bit downward than the A, and the C is in opposite direction. Okay, so again, what ABC is representing in phase space is is equivalent to in a real two-dimensional coordinate space a cluster of bunch of things. They're moving in a different directions. They have their respected velocity. So but with just one point a, b, and c, I can represent the whole cluster in a higher dimensional plane. So what we have done throughout this video is that we define the physical space, phase space, configuration space. In physical space, again, we can define objects easily. We can define the object easily if it is rigid, and it's a two-dimensional plane, or three-dimensional, or four-dimensional. And in the configuration space, if we have a bunch of objects, or if we want to take a system, like we can call it a system, which is system A, system B, system C. So if we want to do mathematics in these systems, it is easy to consider a configuration space which is a higher dimensional space than this plane. So here we can consider the object we can consider these clusters of objects as a whole in a configuration space. So we can consider these all these objects as a point in configuration space. So that makes our mathematics easier. In phase space, we are not only considering the positions, but also their respected velocity and momentum. So we also take into account their positions and their velocity and their momentum. We are just taking all these cluster of objects as a whole. We are considering it as just a point. We are considering the cluster a point in phase space, and we are also taking into account on there are vectors and their respective velocity as a velocity of a point in phase space. So that's it for today. See you in next video. Thank you.